Hi, my name is Henrik Krag Sørensen, and together with my colleague Mikkel Willum Johansen, we've been working to use machine learning techniques to obtain a better grounded, quantitative starting point for studying the use of mathematical diagrams of philosophical interest. Thus, our paper could also have been called Machine Learning to the Rescue of Philosophy of Mathematical Practice. In order to develop a machine learning agent to detect mathematical diagrams, we had some choices to make. We were going to want to identify diagrams as parts of scanned pages, so no structured information would be available. And we were going to train our agent from a hand-tagged corpus of texts from Kralles Journal für die reine und angewandte Mathematik, because that journal is one of the longest-running general-purpose mathematical journals in the world. We iteratively trained our agent based on the fast RCNN framework, eventually supplying it with 1400 positive labels and some additional 7,000 false negatives that were produced by earlier iterations.
So, how could a machine learning agent such as this be of use to the philosophy of mathematical praxis? We can imagine several different uses. So, first of all, simply counting the number of diagrams in different journals and in different time periods would be of tremendous value. It would give us a good idea of the development in diagram use over time, and it would result in a huge and diverse corpora of diagrams that would make it possible to study diagrams in a much more grounded way. Finally, a huge corpora of diagrams will also make it possible to create further machine learning agents. Especially, it would be important to develop an agent that can classify diagrams, so we can study the develop not only in frequency of diagrams, but also in diagram types, and perhaps even investigate how different diagram types spread through various subdisciplines of mathematics.
Our agent performed quite well, surprisingly well to us at least, given the small set of training data we had provided it with. During its training, the agent even made some interesting mistakes and raised some questions for us, such as identifying this continued fraction as a diagram, which we had not included in our codebook. From Mikkel's previous research, we had a baseline, a hand-tagged independent corpus of diagrams with which we could compare our final version. And when we did so, it scored quite well, balancing false positives and false negatives, and thus allowing us to use it to identify diagrams in new and independent corpora. We're currently continuing to develop improved detectors and some interesting classifiers for mathematical diagrams, so please stay tuned.